5, which is about the time value of money. And this is a very interesting chapter. I'm sure most of you will find out. You don't have to worry about any institutional facts, or there's basically nothing to memorize. But it's just some simple technical concepts. If you understand this, well, first of all, it is requirement. Okay? Fundamental concepts behind all the financial analysis. So you need to have a good understanding of all these concepts here. And if you have good grasp of these things, you will enjoy the rest of the semester. Okay? All right. The name time value of money, I think I already explained in the beginning of the semester. You know, one interesting fact or principle in finance is $1 today is worth more than $1 tomorrow, okay? Because there is a chance to invest. When you invest, you receive some interest payment, or you can make some return on your investment. Okay? All right, so here's our basic notation or notational conventions, some agreements we have to make about some notations in this chapter, and so on. Okay? I stands for interest rate per period. It could be quarterly or annual interest rate. Number of periods is denoted by N. PMT stands for payment. Okay? Payment usually refers to constant payment, the same amount of payment per month or per quarter, per year. Okay? So constant recurring or repeating payment every period. Okay? PV stands for present value. FV stands for future value. If you say PV 0, then that typically denotes the first period or starting period. Okay? When you start out today, okay? What's the present value as of today? Okay? FVN is a future value at nth period or time period n. Okay? That's how we denote it. Okay? Little t lowercase t denotes for time. Okay? If you see any capital T, that usually refers to tax rate. Okay? And as we go on, you may see a little bit a little bit different notation, but I will explain any other expression as they come by. Okay? All right. So starting out, we have to understand the difference between the simple interest and compound interest. I think most of you already understand, but the simple interest simply means it's interest paid on principal sum only. Okay? So just on the principal only. That's the important part. Okay? So if you invest certain amount of money, you earn certain amount of interest on the principal. Okay? And every year, let's say you put $1,000 in the bank, okay? And bank pays 3% interest rate. Okay? Then that will be about $30 per year. Okay? And if you withdraw $30 at the end of the year, then your total balance goes back to $1,000. Right? So then in the second year, your interest will be another $30. Okay? That's the idea of simple interest. Okay? But in case you just leave it alone, you don't withdraw the interest payment of $30 and let it capitalize, or in accounting term, it's called capitalization. Okay? Or if you just make the $30 to be added towards your principal. Okay? Then in the second year, effectively your principal becomes $1,030. Okay? So you will earn interest on $1,030 instead of original $1,000. Okay? In other words, you are earning interest on interest. Okay? Interest on principal and interest. Okay? So that's the idea of compound interest rate. Okay? So in the simple interest case, the future value would be 1,000 plus 1 plus I. Okay? And in the second year, you are doing another 1,000 I, and so on. Okay, so it's going to be $1,030. Okay, and you're going to earn $30 interest. No matter how many years you go, you're going to earn the same amount of interest every year. Okay. In the compound case, future value will be 1,000, 1 plus I. Okay, but in the second year, it's going to be the whole thing times 1 plus I, which is 1,000 times 1 plus I squared in the second year. Okay? If you keep going, third year, fourth year, and so on, that's going to be 1,000 times 1 plus I to the power of n. Okay? That's how this formula K is obtained. Okay? All right. So here's the example that I used already, right? In this example, the apparently interest rate is 6%. Okay? So you earn $60 interest payment every year. So after 2 years, your total balance would be $1,120. Okay? But if you leave it alone without withdrawing the interest payment, right, then you are earning compound interest. Okay? So 1,000 times 1 plus 0.06 squared, that's $1123.60. $1123.60. So it's a little bit higher. Okay? Well, you may think, well, $3.60 difference is not much. Okay? But we're talking about the exponential growth here. Here we have this power on top of 1 plus I. Okay? So if you, as the years go on, the difference gets really large between the principal, the simple interest and the compound interest. Okay? So here's I'd like to show you a video. Maybe some of you have watched it already at home. Okay? But this video is, I think it's quite useful for young people like yourselves. Okay? It's something I always emphasize to my children, my own children. Okay? So you may find it useful. Let me see. Okay, let's get back to our subject today. Okay. So now we are getting into the concept of future value. Okay, future value and present value. Okay. So the idea of what we talked about so far. Okay, if you have certain amount of money at this time, PV0 is present right now, starting period. Okay. And save it at the interest rate of I for nth period, n years, let's say. Okay, what will be the future value at period n? Okay, and you know how to calculate it. You can use the formula, this formula, to calculate it. Okay, but you can also use the table, table 1 at the end of our textbook. Okay, it's looks just like this one. Okay. All right, this is a FVIF table, future value interest factor. FVIF stands for future value interest factor. Okay. And it shows basically this part. So 1 times 1 plus I to the power of n, right? That's what we call FVIFIN. Okay? So for different interest rates and different number of periods, okay, they've already calculated all these numbers. Okay? So for example, if you try to find out future value of $800 invested at 7% for 15 years, okay, then you can simply look for this value without calculating. Okay? Look for this value and multiply it to 800. You see it here? Anybody? You need a little larger? This one covers. Okay, here we go. What should you do? What's the number? Okay, 7% for 15 years, 2.759, right? So you multiply 800 by 2.759. Okay, then you're going to get the answer. Okay, so you can use the table. But let me tell you this, using this table, future value, present value tables, they don't do that in real world. Okay? It's just purely for educational purpose in this class. Okay? And after this class, I really advise you not to use these tables. Okay? I'll tell you why. Okay? And everybody uses calculator. Okay? Okay. So that's the future value. And based on that formula we have here, let's say future value was present value times 1 plus I divided by n. I mean 1 plus I to the power of n. Okay? Trying to cut off, reduce the caffeine consumption. So I didn't drink coffee after lunch and just keep saying wrong thing today. Just pay attention and make sure I say the right thing. Okay. Well, sometimes you want to know the present value instead of future value. So in other words, you already know the future value and you want to calculate the present value. Let's say somebody promises you something. Say your friend says, I'm going to pay you $10,000 3 years later. Okay? Let me borrow some money from you, right? Because I have some source, and about 3 years later I'm going to have some cash, right? So I can give you $10,000 3 years later. Okay? How much are you going to lend him or her? Okay? That's the question, right? So when you know the future value, can you calculate the present value based on interest rate and number of periods, right? Well, because we already know this, we can just flip around, okay? And based from this, you divide both sides by I plus I, 1 plus I to the power of n is PV0. Okay, that's how the formula came around, right? So present value is equal to future value times this, or future value divided by this. Okay? That's where the formula came from. Okay? So, just like FVIF, we can talk about PVIF, present value interest factor. at interest rate and the number of periods. Okay? And that's simply 1 divided by 1 plus I to the power of n. And that's table 2. Okay? So in case you need to calculate the present value, you can simply multiply future value by the PVIF. Okay? And you can easily calculate it. So here is one simple example. Suppose you want to find out the present value of $100 to be received 3 years later. Okay? And if you can earn 4% interest compounded annually. Okay? So think about it. In the questions like this, if someone promises you $100 3 years later, okay, then you have to decide what interest rate you're going to use. Okay? This interest rate here is called actually discount rate. I here is called the discount rate. Okay? Because we use that percentage to discount the future value into present value. Remember, future value is larger. Future value has to be larger than the present value. Okay? Because if you invest something such certain amounts today, it can earn interest or it can earn some return, right? So in order to come up with the present value, right, you have to discount future value, right? So we are using this interest rate or whatever I, right, to discount the future value into present value. Okay? How should you come up with this discount rate? What rate should you charge? Can you think about that? Think about it. Today, if you have to make that decision. Someone comes to you and promises some amount of money a few years later, your investment advisor, okay? And say, if you invest certain amount of money into this account, right? 3 years later, 4 years later, we guarantee this amount, right? Then what discount rate should you use? What is the reasonable interest rate you should use? You mean today's interest rate? Today's interest rate. Why? Okay. Okay, right. Because what he's saying is if you invested certain amount of money, whatever, X dollars, okay, if today's interest rate was 5%, right, then it's going to earn 5% return for the next 5 years or 4 years or 3 years, how many periods, number of years, right, it was supposed to be, right? So in order to be fair, right, you have to, if someone promises a certain amount, right, you have to discount it at the same rate, right? That's the idea of opportunity cost of money, right? If you invest certain amount of money today, $1,000, whatever, right? Then if you can earn 5% interest for the next 3 years, okay? Then someone promises a certain amount of money 3 years later. How much is it worth today? Or what interest rate should you use to discount the future value into present value, right? Then you should use the same interest rate, right? So whether you try to calculate the future value like this or try to calculate the present value like that, right? This I should be the same. It should be interest rate, the discount rate should be equal to today's interest rate, okay? Or better yet, market interest rate. You have to find out how much interest return you can earn from the market, right? To be fair. Yeah? So the concept of discount rate is exactly the same thing as interest rate, but we just use two different names. Okay? If you are earning interest on your money, it's going to result in future value. We call it interest rate. Right? If you are trying to come back, right, from the future value to the present value, which means you have to discount it, right? Then we call the same rate discount rate. Okay? So make sure you understand that concept. Discount rate is the same thing as interest rate. Okay? All right. Before we go on, let me introduce timeline. Timeline. Okay. This is an illustration that we frequently use in finance. Our textbook uses it, but it doesn't really explain it specifically at any specific point, right? But when you are dealing with more complex financial analysis, if you illustrate the situation using timeline, it definitely helps. Okay? You will see that, right? So we use a line, and we illustrate number of periods. Let's say n is 5, 0, starting from today. Okay? And we draw a cash outflow. You know, let's say you are investing today. Right? You're putting some money in your bank account or somewhere in your stock market account, right? Cash, that's a cash outflow. When you make an investment, that's cash outflow because your money is coming out of your pocket into bank account or somebody else's account, somebody else, well, or stock account or stock manager's account, whatever, right? Whenever there is a cash outflow, we draw a down arrow, okay? So we write $800 cash outflow, okay? And let's say in this problem it was 15, so you can say n is 15. You can say, you don't have to mark all the, okay? And you can simply say, well, typically you say n is 15, I is 7%, okay? And then in this question, we're trying to find out the future value, right? So in the future, here's one simple rule about the finance. If you want to receive something in the future, you have to invest now. In other words, there has to be one cash outflow and one cash inflow. This is especially important when you use calculator. Okay? In the calculator, you have to specify which one is which one is cash outflow and cash inflow. Typically, you make the cash outflow a negative number. So when you plug in $800 in your calculator, you have to change sign to negative. Okay? In the timeline, you don't have to do that because you already know it's a cash outflow. Okay? If you put 800 and whatever, both positive number, then your calculator will give you error message. That's an error. There's no way you can do that. Okay? So let's say FV. This is how we illustrate this question. It's a very simple illustration. So in very simple problem, you don't need any illustration, really. But sometimes we deal with a quite complex problem. Okay? Then you will see the illustration really helps. Okay? So we'll deal with more of that as we go on. Okay? Okay, so here we can use PVIF in case you want to come back to the present value. Okay? If we know the future value and we want to find out the present value, we go to table number 2, which is PVIF table. Okay? And that was what? 3 years and at 4%. Yeah? So 3 years at 4%, that's 0.889. Yeah? So you just multiply 100 to 0.889, and we know the present value is $88.90. Yeah? In other words, because market interest rate is 4%, right? If you invest $88.90 today and leave it there for 3 years, okay, then you can make it grow to $100. Okay? That's the idea. Okay. All right. So again, you can use the table in class, but here are some comments I talked about. Right. I strongly recommend you to use financial calculator, yeah? Because using the table have several problems, several shortcomings. Okay? Tables do not list all possible values of I and n. Okay? So as you see here, it shows 1%, 2%, 3%, and so on. If you're trying to calculate 6.25%, there's no way you can use the table. Okay? The best you can do is kind of interpolate, right, between this number and this number and say, well, since 6.25% is 1/4 this way, right? So you can calculate the difference and multiply by 1/4, 0.25, right? But that's not going to be really accurate. Okay? If you're dealing with small money like $100, it may make just a couple of cents difference. But if you're dealing with hundreds of millions of dollars, right, that kind of difference is unacceptable, right? So, that's the first problem. The second problem is it lists, I don't know how many years it can go, but it cannot list all the years, okay? So, table has definite limitation. The factor, those numbers you see in the table have been rounded at the fourth digit. Again, what that means is all the numbers go up to third digits below the decimal point, which means this number has been rounded up from the next digit, fourth digit, right? And again, if you're dealing with large amount of money, right, that third digit, fourth digit difference makes a huge amount of difference, right? So that in practice, in reality, this is not acceptable. Okay? The more important problem in this class, even in this class, you can't use the table in some cases. Okay? Like, let's say I give you the problem here. Okay? Present value is 800. So somebody promises you, if you invest 800 today, right, I'm going to give you $3,000 5 years later, or maybe 10 years later, right? If you invest $800 today, I'm going to give you $3,000 10 years later. Should you accept that offer? How should you make that decision? What do you need to know? Interest rate, right? In other words, what is the rate of return in this investment, right? And if you find the rate of return, you're going to compare it with what? Bank interest rate or market interest rate, right? So to see if return in this investment is better than what's available in the market today, right? So this is what we call internal rate of return, IRR, internal rate of return. So you should be able to calculate using present value and future value and say number of periods, right? You should be able to calculate interest rate, right? In this table, you can't do that using this table, right? Because if somehow it comes out, the number comes out exactly. Let's say you invest $1,000, okay, and 10 years later, somebody promises This is, you go back to FBIF table here. Okay, right. So let's say you invest $1,000 and 10 years later, somebody promises $1,898 exactly, right? Then you know, rate of return is 6%, right? If present value and future value happens to be exactly the multiple of this, right? Multiple of this multiple of the present value, then you can find the interest rate exactly, right? But in more general cases like this, it's going to be hard to do that. There's no way you can calculate that internal rate of return exactly, right? But if you use a calculator, it's a piece of cake, right? You can do it right away. Yeah? Okay, so I think you'll like it when you start using calculator. Before we go to annuity. So why don't we start some exercise here? How about problem number 5? On page 180, problem number 5. How much will $1,000 deposited in the savings account, earning a compound annual interest rate of 6% be worth at the end of the following number of years? Okay. How about 5 years? 3 years, 5 years, 10 years, let's say. See if you can use the table first. Present value is $1,000. We're trying to find the future value. N is what? A is 3. Question A says 3 years later. And what about the interest rate? 6%. Okay, so that's how you illustrate this problem using timeline. Okay? And so future value is 1,000 times 1 plus 0.06 to the power of 3, right? If you like, you can use your calculator or regular calculator. You don't need financial calculator for this, right? And you can easily calculate it, right? But you can use the table. What's the number? 6%, 3 years, 1.191, right? So you know that it's right away $1,191. Okay? And you can do the same thing for 5 years and 10 years. Okay? All right, let me pull up a financial calculator now. Why don't you pull out your financial calculator? All right, this is how HP12C looks like. Do you all have this? You can download the free version from in the internet, right? Did you try? I think Vicino. How many of you have Vicino version? Yeah, I think that's probably the closest, and it's free and it's got most of the functions that you need for this class. Yeah? All right, so here there are black keys and there are blue keys and there are gold or orange keys. Okay? So, you know, if you want to use these functions like program, finance, register, prefix, you have to you have to press this one first, okay? And then if you press F and CLX here, that means you are clearing the register, okay? So make sure you do that before you get into a new problem. The reason is when you put in some numbers, okay, here, there are 5 keys on top here. Excuse me. N, I, PV, PMT, FV, you know what they are. These are the crucial 5 keys for financial functions. Okay? So in most of the problems, you will enter at least 3 of them. You know, number of periods, interest rate, and the present value. And you can calculate the future value, right? Once you do that, this calculator remembers that. It keeps those numbers so that you can do further calculation using the same number of periods and same interest rate. So when you get into the new problem, new problem with a different N and different I, you have to clear the register, right? Otherwise, you're going to get a wrong answer, right? So, excuse me. Before you get into a new problem, it's a good idea to make it a habit of clearing the register. Just press F here and CLX here, okay? And it clears all the register, all the memory. Okay? Okay. So, problem like this, okay? What you need to do is 1,000. And that's the present value, right? So click on PV. And if you noticed, when I typed 1,000, there was no 00 here, right? But when I pressed PV, it adds 2 zeros. That means the calculator is letting you know that I got it, okay? I got it memorized as a present value, okay? And then interest rate was 6%. Don't type 0.06. You have to type percentage, right? So if it's 0.06, that's 6%. Just click on 6 and I. Yeah, you see the same thing? As soon as you press I, it becomes 6.00, okay? That means your interest rate is recorded now, okay? And number of periods, 3 years, okay? So 3 and N, okay? So we are ready now, okay? So since we have entered present value, I and N, and we are looking for FB, future value, right? So all you need to do is just click on FB. All right, here, negative 1,191.02, okay? Why do we get negative number? What? Okay, yeah. I told you, in reality, right? If you want to receive something in the future, you have to invest now, right? But I entered positive $1,000, okay? So in fact, what I did was opposite. I told the story to this calculator that I am borrowing $1,000 right now, or I am withdrawing $1,000 right now, right? How much do I need to pay back later? Okay? So since I entered positive $1,000, right? The calculator is thinking that I am borrowing right now. It's a cash inflow. Money is coming into my pocket. Okay? And that means in the future I have to pay it back. Okay? So that's why it says negative 1,191. Okay? So here we have slight difference. When you use the table, the answer was 1,191, right? When you use calculator, it's 1,191 and 2 cents. Again, it's a small amount of money, and only 3 years. Doesn't make much difference, right? But if you're dealing with a lot of money and longer periods, the difference is significant, right? So you should trust your calculator, right? Not the table, okay? All right? just for the fun of it, if you want to do question C, say 10 years, what are you going to do in calculator? There are many different financial calculators. There are two popular ones, HP12C, this one, and Texas Instrument TI BA2, BA2 Plus. Okay? And there are pros and cons. This calculator is slightly different. I'll show you what later. Maybe I can show you right now. Well, right after this question. But I prefer this calculator. It's a lot easier to use. Okay? So, for example, if you want to do the next question, what about 10 years instead of 3 years? All you need to do is say 10 and N, right? You just change the number of period and then click FB. That's it. Because the calculator remembers all other parameters like interest rate and the present value, right? It just recalculated the answer using 10 years of period, right? So it's much easier if you try to use something like TIBA2 plus. Okay? Okay. There are many more steps. Okay? The reason why some people prefer that is it works just like regular calculator. This calculator has one drawback, which is it uses different algorithm. Okay? So if you want to do a simple calculation, let me clear the screen here. Let's say 2 times 6. 2 times 6. Of course, the answer is 6. I mean, 2 times 3. 2 times 3, right? In normal calculator, you would do 2 times 3. Doesn't work here, right? If you do that. What you have to do is you have to do 2, enter, 3, multiply. Okay? It's a slightly different algorithm, right? It's but the reason why they have here is if you do complicated calculations, this helps. Okay? So believe it or not, in financial world, this is the standard calculator. If you go to Hanyang Women's College, there's a Shinhan Bank, right? Shinhan Bank branch at Hanyang Women's College. The branch manager, Ms. Hong 소장님. Okay? I went to her to discuss how to send money to the United States. Yeah? And I saw this calculator right on her desk. Okay? And immediately I could see that I could trust her. Yeah? Okay? She is a financial professional, right? She's a very nice and very smart lady. Yeah? And this HP12C has been around for more than 20 years. I would say about almost 30 years. Yeah? And a long time ago, believe it or not, we did this. Using this. This is the side way. Okay? So the way you use calculator is you hold it like this and use your thumbs, just like you text these days. Okay? And texting was not around until about 10 years ago, right? But 30 years ago, financial professionals were doing this already, right? It's a lot. When you use 2 thumbs instead of doing this, okay, with a regular calculator, you can do a lot faster, okay? So with the left thumb, you press all the functions. With the right thumb, you press all the numbers, okay? So, that's I guess, beginning of texting motion, okay, 30 years ago. Okay? And it's very easy to use once you get used to it. Okay? And, when you keep using it, you'll understand what I mean by that new algorithm, different algorithm makes the calculation simple. Yeah? Okay, so much for the calculator. Let's say, let me introduce a couple more functions here. How about problem number 3? Problem number 3. Let's try question number C, 3C. What you see here is actually called the gold version. This is an original version. It's been around 30 years. Okay? What you see these days, if you want to actually buy one on the internet, you'll see a platinum version. Right? Platinum version is the silver instead of gold. Okay? But it's got a few more functions, and it's a lot faster. Okay? 홍 소장님 had this platinum version. Okay? I think they're probably more than $100, maybe close to $150. Okay, so here the question is, what is the present value of 800 to be received at the end of 8 years, assuming the following annual interest rate? 4% discounted annually. You know what to do. Okay? So we know the future value and trying to find present value. Right? To be received at the end of 8 years. So n is 8 and future value is 800. We're trying to find present value. Okay? And the thing is, we don't know, we know different, the interest rate. Okay? So 4% discount annually, well, that's easy, right? You can just, let's clear the register here. And then put 800 as future value, okay? And 8 as the number of periods, and 4 as the interest rate, and just click on present value, right? So negative 58455, right? That is $584.55. So if you invest $584.55 today at 4% annual interest rate for 8 years, then you're going to end up with $800 in the future, right? That's one thing. The second question, B, says 8% discounted at 8% discount. Okay, forget about that. The same thing, right? 20% discounted quarterly. So instead of annual interest, we are dealing with quarterly discount, quarterly compounding. Quarterly compounding. Okay. So there is in some financial situations, there are semi-annual compounding, quarterly compounding. In some cases, they do monthly compounding. Your credit cards, if you use your credit card, okay, your credit card interests are daily compounding. So when they say 20% quarterly compounding or discounted quarterly, it doesn't mean 20% every 20% every quarter. We're talking about annual interest rate of 20%, but instead of compounding just once, you compound 4 times. Okay? So there are 2 different ways you can do this. More primitive way, if you don't have your financial calculator, okay, then you can divide 20 by 4. which is 5%. Right? So what that means effectively means 8 years times 4 is 32 quarters. Right? So you are compounding 32 times. And each time you are using 5% interest rate. Okay? So it's just like 32 years at 5% annual rate, the same thing, right? Or you're talking about 32 quarters at 5% quarterly interest rate. You will get the same answer, of course, right? Because n is 32 and I is 5. You can do it that way, right? So when nobody reads this fine print of this credit card statements, right? When you first sign up for credit cards, there are lots of things you have to read. Okay? But if you read it very carefully, you will see that the credit card's interest are compounded daily, right? So if they charge, say, 24%, okay? They divide 24% by 365, right? And whatever comes out they use this interest rate to compound every day, right? You know why? Any guess why they would do that? Because it's to their advantage. Okay? Their interest income will be higher, right? Rather than using 25 or 24% at compounding just once, or 12% compounding it semi-annually. Okay? All right, so you can do that, or here's another way to do that. Using the calculator, clear the register, and 800 for future value, okay? And 8, enter, 4, multiply. What did I do? Just calculated the number of quarters, right? So 8 times 4. 8 times 4. So I got 32. And then press N. So I just entered 32 as the number of period. Okay? And then 20 divided 20, enter, 4, divide, right? So that's a quarterly interest rate, okay? And then press I. Well, that's not what I do here, okay. Oops, messed up. Okay, let me try again. 20, enter, 4, divide, I, okay? And then calculate present value. 167.89. Okay? 167.89. That's the answer. Present value is. Okay? I think I was thinking slightly different way, but what I just did in the calculation was the one I explained just now. Right? You just divide the 20 annual interest rate by 4. That's a quarterly interest rate, okay? And number of quarters. Okay? Just for the fun of it, let me change the question here. Let's say present value is 100, and we don't know the future value. So 8 years, say 20%, okay, to make it simple, okay? So why don't you calculate the future value in this question? Present value is 100, okay? The second time, the same thing, present value of 100, right? But instead of annual compounding, use quarterly compounding, right? Can you do that quickly? give you 1 minute. So clear the register. And 100 as the present value. And 8 is the number of years. And interest rate, what, 20? Interest rate. And future value is 429.98. Okay. This time use quarterly compounding, right? So the number of period it will be what? Number of period will be N will be 32. I will be 5. Try what happens. See what happens. What do you get? 476.49. Okay, so you see the difference, right? Using the same interest rate, if you do more compounding per year, right, the value increases, right? That's why the credit card company does daily compounding. Okay. All right, we're going to continue Thursday. We'll try to finish this chapter on Thursday.